Hi, welcome to the Tech Bytes session. Today we're going to speak about something which is the most happening talk about deep learning. So without wasting time, a quick Tech Bytes on deep learning. So we all know deep learning tries to solve a further complicated problem than a machine learning. So it is made of a multi-layered deep neural networks, okay, that mimic the activity of the layers of neurons in the neurocortex. We all know the way the human brain thinks. If you want to simulate it and then see how you can apply this into multiple layers, that's what we're talking about deep learning. So each layer tries to go a little bit deeper, understand a little more detail in terms of what is happening. For example, if you're trying to provide an image, a human being is trying to think about an image in parallel about what this image is and quickly recognize it, like it's a cat, it's a dog. But if you want to automate it, like if a system or a machine has to see it and tell you what it is, the first layer learns some basic features like maybe an edge of an image, particular note of sound. Okay, then it recognizes more complex features like corners. Then it tries to get a little more complex, like recognizing object faces, whatever it is. So that is how the you actually train up your entire deep learning perspective. Okay, so it goes very far away that brain was an example of Google. So if you really see, Google has created brain. It's a deep learning project and used in many of the Google products, which you may not be aware of. Maybe it's a search engine, voice recognition, blah, blah, blah. And even when you use your Android phone and use all your voice commands, use there also you can see that Google uses the deep learning perspective. Very interestingly, we all know like we're using the Google Cloud platform. It also enables deep learning development. If you want to really develop something very custom based solutions for end customers, so it's got an open source deep learning software stack called as TensorFlow, and you also have the Google Cloud Machine Learning Cloud ML. So Google has been very creative in this particular area for a very long time and trying to do a lot of interesting activities around deep learning. And then if you really see it from the IBM, and what they were doing is that neural networks like DeepMind of Google or Watson need to perform billions of tasks. So we all know what is Watson, so you can just Google it and search. But DeepMind and Watson need to perform billions of tasks in parallel. So you require numerous CPU calls, large amount of data has to be fetched. So you're also able to see that there is a lot of innovation happening from a lot of these OEM vendors on what to do next with the deep learning. So let's take an interesting other case like Facebook. Now, Facebook is also constantly trying to bring in a lot of innovation using deep learning. For example, Facebook is trying to develop and apply the deep learning technology for a lot of things. Like, for example, to capture contextual dependency between words, recurrence, and position invariant semantics through convolution. Okay, so it's doing a lot of interesting work, Facebook. So what you are observing in the social networks while you're searching for a friend, and when you get a lot of inputs based on your your comments in the blogs, there are a lot of things, interesting thing like the way the human brain works. The machine can automate a lot of deep learning syntax and semantics to a specific domain. Let's take it to industry. You can see that Ford researchers know that they had developed a very accurate approach to estimate a moving vehicle's position within a lane in a real time. Okay. So what they did is they created something called the deep lanes to process input images from two laterally mounted down-facing cameras, each recording at an average 100 frames per second. And they trained this neural network on the NVIDIA DevBox and by using the CUDNN accelerated cafe deep learning frameworks. So this is one example of how they integrated the deep learning frameworks, including Cafe, CNTK, TensorFlow, Theano, and Torch to really develop this entire solutions for Ford. So Ford is really trying to be creative in the automobile industry. Similarly, you can see the life science industry uses deep learning for drug discovery, maybe disease progression, like they can understand the progression of diseases like Parkinson, like researchers at the Australian National University is doing that. There's so many activities happening in the life science industry. And what deep learning is supposed to do is to be the future of digital personal assistant like Siri or Alexa or Cortana, right? So you give any commands and these assistants will be able to understand and get it done. And it's also going to be the future of your web search, marketing, product design, whatever you call. So there are going to be very interesting innovations coming from Google, Facebook, Microsoft, Amazon, Nvidia, Apple, AMD, IBM, each of them releasing different products. So let's watch for the space and understand. It's a very interesting area to really look at how the things are going to turn around the next 3 years to come. So thanks for watching. See you in the next session.